Yes, Gulf moisture surge. Let's take a look and see what that is. This is observational data for a station close to here. You can see yesterday afternoon around 22:23 5 to 6 p.m., dew points were running about 18 Celsius, which is about 64 Fahrenheit. A few hours later, they increased to 21, which is about 70 Fahrenheit. And they increased during the night up to 22. At one station a little closer to here, the surge was accompanied by an increase on the wind speed up to 10 to 15 knots, and some of the cumulus that you saw in that opening clip. And then later during the night, overcast, low overcast, fog, and that lifted later during the morning into cumulus. Now you can see it here on this model run from yesterday. Watch down in the Houston area. You can see this area of elevated dew points coming up. And then we see this surge running northward. This is about 6 p.m. And then it kind of rolls forward as a sort of warm front. And then by midnight, it's already in the Dallas-Fort Worth area, past Shreveport. And this shows up a little bit better in the severe weather composites. And watch that Houston area right there. See it coming together? It's very subtle, but that's it right there. And we can see that spreading north. See, that's pretty cool. And basically what that is, that's a reinforcement of tropical air there from the Gulf of Mexico. Anyway, let's take a look at the surface map and see what's going on. Here's conditions across the U.S. this afternoon. Still finding the polar fronts way up north there in the northern plains. And the tail end still running through the Great Basin area. We do have the westernmost part of that front moving through Northern California, and I would expect to see some of that cold air start filtering down into the San Joaquin Valley and into Nevada. In the desert southwest, it is hot. 104 there at Phoenix and 107 at, there's that station again. That's north of Yuma. I want to say Lake Havasu City. It's going to be somewhere in there. And we even have 101 at Safford. So, yeah, we're cranking up that furnace. Also very hot there in Albuquerque and in the Farmington area, and also extending out into the eastern New Mexico area. And with that air also being dry, that's defining the edge of the dry line there along the Texas Cap Rock. Ahead of that, we've got some rich Gulf moisture flowing northward, as we saw. Now, this particular dry line, I kept that out around the 60s dew points. But up further north, I went with kind of a weaker upper 50s to lower 50s. And that's because I think the 30s and 40s dew points are a little more significant for the dry air, and the mid 50s up probably represent the moist air. What I think of as far as criteria is, what do we need to get storms going? And if we take a closer look at a surface map, yeah, you see that 75 over 55 at Rapid City. That's probably enough to support some storms. Also 73 over 57. Yeah, that'll support storms. 81 over 56, possibly. 79 over 43, probably not. And you can definitely get storms in that, but they're most likely to be elevated. So that is what I would consider to be the dry line out in the high plains. So on a day like this, probably a good day to be out around the Black Hills. And we'll take a look up there on the satellite and start out with the infrared. Well, what does this tell us? This is not going to show the low cumulus clouds so much as it will the high altitude cirrus and altocumulus. So this infrared imagery can actually be useful for finding upper level disturbances and also identifying the the deep moisture surges coming from the tropics, like here in Florida. See that big band of high cloud? Well, some of that's going to be debris, but I would probably go back to this and see if the precipitable waters are kind of high. And we take a look, and yeah, that's indeed the case. In Texas, even though we had a moisture surge here, it doesn't have very much depth. That's mostly in the lowest 2,000 to 3,000 feet of the atmosphere. And you can see that on the aerial footage. Look up above the cumulus. It is clear blue sky, indicating dry conditions in the mid and upper levels. We also see thunderstorms on the infrared imagery. Those show up pretty well. Looks like a few of those in southern Ohio and southern Indiana, and one lone cell in southwestern North Dakota. And we can also see that the weather patterns in Wyoming and Colorado favoring maybe a little bit of forcing, maybe some mid-level convection. We know that that's back behind the dry line, very dry air mass, but you can still get elevated storms if there's enough mid-level moisture, and that could be what's going on in parts of the Central Rockies. So let's zoom in there on the Black Hills and see what's going on. And for that, we want to go to visible imagery. You can see the infrared imagery kind of coarse and not very sensitive to the low levels. And we can see a much different picture there. This is the Black Hills right here, Rapid City just northeast of that region. And we do have towers going up around the Sturgis area and the northern Black Hills. And let's run a satellite loop. So this is how it looks as of 2 p.m. Central or 3 p.m. Central. And we got to keep in mind that with the moist layer kind of sitting out here with the mid-50s dew points, upper 50s dew points, these storms, when they cross over and get into that air mass, they can actually develop lower LCLs, better CAPE, and better potential for severe weather. And that could also be what could happen with the Black Hill storms. Now, College of DuPage does allow us to overlay the plots, and we'll do that here real quick. So I'm not too sure this gives us all the stations, but, you know, at least it's kind of helpful. And what I'm looking at specifically is the dew point temperatures. I'm looking for where the moist layer is, and you can see the 61s sitting out here in northern Nebraska. Now that could be significant later during the day as it interacts with these storms coming off the higher terrain. The moist layer, well, 56 here, 55, 55, so it's pretty decent all the way up. Anywhere east of, yeah, pretty much, let me just cover this area here. All those dew points looking favorable. And that would probably extend all the way out towards Pierre. Yeah, Pierre, interesting little town. I often wonder what it would be like to live there. See, state capital of South Dakota. Not much to the street pattern there. Looks pretty typical what you would see in Oklahoma. One thing I like is you notice there's an absence of telephone poles. That's good. You don't see that too often in this part of the country because they really clutter up the skyline. Yeah, let's check out one of the neighborhoods there. That's kind of a pretty subdivision. Although, you know, you're out in the middle of nowhere. I think you have to drive to do anything except shop at Walmart. Okay, so even without looking at model data, we're starting to get a feel for what's going on. You can see the anvil streaming west to east there. So there is some bulk shear present. The only thing is that, you know, even though there's dew points around the lower 60s, there's an absence of low cloud. So there may not be much vertical extent to that moisture. However, with the proliferation of cumulus out there in central Wyoming, I think there's some upper level forcing approaching the area. So going to the model charts, it's not quite breaking out anything in the Black Hills, but let's check out what we should be looking at dew point. Let's see what the air mass looks like. You can see that moisture axis is pretty much where we identified it. Maybe it's overdoing the moisture a little bit. Okay, let's do a forecast skew-t. This is going to be somewhere south of Rapid City there. And what I'm seeing here is some depth to that moisture, maybe about 100 millibars of moisture. That's not too bad, about 75 to 100 millibars. There's a very slight cap, which is good. Mean mixing ratio about 11 to 12 grams per kilogram, which means we're going to get an LCL up here. That's a little bit on the high side. That's about 1.8 to 1.9 kilometers. But we do get some cape, moderate cape there, and some good turning of the winds. And that's given us some curvature in the photograph. Not a lot, but it's there. And then what we want to know about is storm character now. So we've gone over the potential for severe weather. Let's look at storm character, assuming that they do go up. Okay, good storm motion due to the strong upper level winds, and you can see that the mean cloud layer winds are about 40 knots. The right motion vector carrying storms to the southeast at 25 knots. So it looks like there will be a fast initial eastward movement, then they'll slow down and move more towards the southeast. You can see that good helicity being swept out there. And let's see, for the type of supercell, we can look at this 9 through 11 kilometer wind, and you can see that little purple thing. You may want to go back and look at that video that I did on using Sharpie. That'll explain more about this. But you can see we're in the classic supercell part of the spectrum due to the good storm relative anvil level winds. The mid-level flow looks pretty decent. It's well above the threshold at about 28 knots, looks like, and good storm relative inflow, almost 30 knots. So there are some good parameters today. And you can see the storm slinky there showing that a parcel rising from the updraft base all the way up to the top parts of the storm gets lofted some distance to the northeast. And that provides for some separation there between the updraft and downdraft. The STP elements here, well, the overall index kind of putting us well above the non-tornadic range, kind of in the top part of that whisker, and putting us on average in the EF1 range there. So today, matched up with other cases that mostly produced EF1 tornadoes. Initiation. It's got storms moving out over the plains around the Rapid City area and then dying out around 7 or 8 p.m. So yeah, I would think probably the best potential, maybe we're going to see those storms move off the Black Hills. High resolution rapid refresh going a little bit too far north. But I think we could expect to see these storms here move out in this area. So I might want to be maybe around Ellsworth Air Force Base, maybe a little to the kind of in that vicinity for a starting target. And just wait for the storms to roll out, and I think there could be some potential right in that area. These storms here, these are probably a little bit more problematic. We saw from the dew point plots a lot of moisture erosion in this area, so that's going to negatively affect those cells which are right there. So we're going to have kind of like high cloud bases and not much potential for rotation. You can see those little artifacts there as the cold pools dump out moisture into the lower levels. I think there could be some hail in that, but maybe some photogenic structures. But I would be surprised to see a tornado out of those. The main potential, of course, will be up in South Dakota. We haven't even looked at the SPC outlook. Let me go to that. SPC Day 1 outlook, enhanced risk for that area we talked about, and then it kind of tapers off as you go south. Tornado probability, 5%. That's modest. And let's see here. Yeah, see, they're talking about that corridor of low-level moisture. Okay, nothing specific about tornadoes, but I would expect, since they're not focusing too much on tornado potential and they're talking about wind, I would probably go back and look at the decapes. Make sure that we're not going to see a lot of outflow structure. So let me go back and go to 20, let's go to 21Z. Decapes are 848. That's not too bad, actually. Because the cold pools will kill you. Or kill your chances for seeing tornadoes. And yeah, it's moderate. The thing is that, you know, there's not a whole lot of dry air in this level. And we're not seeing a whole lot of pore moisture and high LCLs go up into that storm. So I think this is actually some decent potential here for rotating storms. Yeah, see, now that I'm pulling up these photographs, I'm not seeing a whole lot of 0 through 1 kilometer helicity. So I think ultimately what it's going to come down to is whether this 0 through 2 kilometer helicity is significant. And if the storms can move off the photograph even more, that'll be even better. So, yeah, I think there's an outside chance there of tornadoes. There's some good things and some bad things about that photograph there. All right, my brain is getting numb looking at this, so let's move on. Okay, we did a little bit of editing and came back to this, and we're pulling up the latest data. And we can see that we've had a Turkey Tower instance. Storms tried to go up and didn't produce anything. Let's run that through. See that? See, they're just putting out anvils and nothing. However, you know, heating is still going on. You've still got the orographic lift on the Black Hills, and the model has indicated some potential for development. So I think we'll see this area regenerate in the next couple of hours. So what I'm expecting, for one, this area will probably regenerate later on this afternoon. There's still a few hours for that to happen. The other, these cells down here along the Nebraska border, those are making good progress eastward. And I think they're outrunning the models. Now, the models were indicating erosion of the moisture in this layer right here, so I would expect those dew points to go down. But eventually, these storms will drift into the vicinity of that main east moisture axis, way out here. See those dew points, 62, 68. And if that holds on, maybe in 3 or 4 hours, we could see something going on right there. Yeah, you know, it appears the high-resolution rapid refresh holds onto this moisture axis right there in Nebraska. Let me drop one sounding in there. Yeah, kind of a very thin, favorable area. It's not very well capped, so there's probably going to be numerous cells. The other problem is that there's poor winds in the low levels, so that'll be working against these cells. So probably, you know, a window of some severe weather, probably in this area corresponding to the moisture axis, but not much rotation. I think the best potential for that might be up in South Dakota. And even though it's not, yeah, the winds are backed around 20Z, but it looks like they start veering. And then we kind of lose the favorable environment around late afternoon. So anyway, yeah, these are some things I'm finding as I go through the data. And you're kind of seeing the thought process I'm going through. So, yeah, all in all, the soundings we looked at earlier looked great. But as the afternoon goes on, things actually look a little less favorable. Okay, we're 20 minutes in, so let's do our whirlwind forecast. Starting out for today. So starting out for today, the main dominant feature is the Bermuda High covering this large area in the southeastern U.S. and bringing up moisture into the southern states. Also another feature is the approach of cold air from the Pacific and from Canada. There's all the cold air. So we're kind of setting up a battleground. And moving forward, going into Friday and Saturday, the cold air does make some progress south. This gets into Saturday and Sunday, and you can see what's effectively a backdoor front. You can see that this replaces the Bermuda High. See that large area of high pressure coming out of Canada? That's the next shot of cold air interacting with Cristobal coming up from the Gulf, and also this Pacific system across Wyoming and Montana. This is Saturday night. Okay, so yeah, another shot of cold air coming in to California, breaking that heat wave there in the San Joaquin Valley, and you can see the cold core there, 540 decameter heights coming into western Nebraska. And what's going on with my window? Okay, we're back now. Let's see. There comes Cristobal coming up to the New Orleans area, 995 millibars. Now these dynamical models, these global models, don't necessarily get the central pressures correct, but 995, that puts us into the tropical storm range. At least it looks like a tropical storm on the models. Very good punch of cold air coming into the western U.S., and winter is back, and we got snow coming in for Sunday. There goes the tropical storm into Louisiana right there. The cold air works its way into the Rockies. Snow showers in western Wyoming and western Montana. Of course, the bulk of this energy goes up into the northern plains, not surprising there. Tuesday and Wednesday, cold air finally moves out onto the Great Plains, but it's significantly modified, so it's going to be a little bit cooler and probably just fair weather across the Great Plains. The remains of Cristobal affecting the Mississippi River Valley all the way up to Minnesota there around midweek. Then going into late in the week, kind of stagnant. Oh, yeah, we pick up some other tropical thing. What is that? Yeah, it looks like some sort of tropical depression, maybe. Yeah, that's probably the remnants of Cristobal. So the moisture, I guess that gets picked up and advected north, and the circulation just kind of hangs around Mississippi and Alabama, at least according to the GFS. On the other hand, some cool continental air affecting the Midwest, keeping the temperatures down and bringing a cool northerly flow into much of the southeast. Next big change, well, more cold air coming out of Canada, that's for sure. See that right there? Northerly gradient and another Pacific shot for next weekend. And the Gulf, well, it's just barely open there. Kind of a recirculated Gulf pattern. And maybe at the very end we start tapping the deep tropical moisture once again for the 17th, 18th. And with that, with lee side troughing and upper level flow strengthening across the Rockies, we get a chance for severe weather going once again in Kansas and Nebraska. Okay, that's about all I got for today. We're up to 25 minutes. I don't know if these shows are running too long. If y'all are getting bored, let me know. If y'all like long shows, also let me know. You can write metlab@weathergraphics.com and let me know what you think. All right, take care. Tomorrow is our Friday edition, and we will see you then. Bye-bye.